Okay, you guys, so today we're going to talk about the second half of section 9.1. And today we're going to talk about making mistakes. All right, mistakes happen. They happen all the time. But we want to, like in statistics, we want to keep the probability of a mistake occurring to be as slim as possible, right? So when you're working on hypothesis testing, there are two correct decisions. You can reject the null hypothesis when you're supposed to reject it because it's false. Or you can do not reject the null hypothesis when it's true, so you're not supposed to reject it. And those are both good decisions. But then there are also two mistakes that occur. So the first is called your type 1 error. And your type 1 error is your alpha. So if alpha equals 0.05, then that means that you have a 5% chance of making a type 1 error, all right? Alpha equals 0.01, then you have a really small chance. You only have a 1% chance of making a type 1 error. The type 1 error is when you reject the null hypothesis, but it was true, and it should have been do not reject. A type 2 error is something that we call beta. Okay, it's like a cursive B. It's really difficult to compute. We're not required to compute it. We do need to understand a couple things about it. We're going to get into that at the end of this chapter. But the type 2 error is when you do not reject your null hypothesis when it is false. Okay, so as we go through a couple examples, right, before we do statistical examples, we're going to do some silly examples or real life examples, okay? Not necessarily silly, but more realistic. There's a couple ways you can look at this. So sometimes people will use a table like this to come up with their decisions, okay? And then sometimes people are going to work on it with sentences. You can kind of pick and choose whatever clicks for you is a great strategy. All right, so our two correct decisions is when you reject your null and your null is false. You were supposed to reject it. Or you don't reject your null and your null is true. Good, correct decision. So type 1 error is you reject your null and your null was true and you shouldn't have rejected it. And that's when you get a type 1 error, and that's your alpha. Okay, like we put up here, your level of significance is alpha. Depending on what font the worksheet uses, and if it's italics or not, sometimes the alpha symbol is going to look a little different, but it's always alpha. A-L-P-H-A, alpha. Whoop, there we go. Okay, we also, if you get do not reject your null, but the null is false, then that's a type 2 error, and that's our beta, and we'll get into that at the end of the chapter. So if we consider these scenarios, so our first scenario, if we talk about the fact that if we have a court case, okay, and I give you the defendant is innocent and the defendant is not innocent, all right, then if the null hypothesis is true, then that means that they are innocent. Okay, if the null hypothesis is false, that means they're not innocent. Notice we don't want to say guilty, we just want to say not innocent. We always want to go with the opposite, okay, in words, not changing the vocab, but just going with the opposite. If you reject the null, then what does the jury do? If they reject the null, that means they say this is bad and this is the truth, which means they convict the person. If they do not reject, DNR is a common abbreviation for that. If they do not reject the null, that means that they declare that the defendant is innocent, all right, which means that they're going to acquit them. So, what are the correct decisions? If your null is false and you reject it, they really aren't innocent and they're convicted. That's a correct decision. Or they're innocent and you acquit them. That's a correct decision. The two mistakes are here. If you reject the null, meaning you convict, but they were really innocent, that's a type 1 error. We always use Roman numerals, not a 1 and a 2. That's a mistake, right? If you convict an innocent person, that's a mistake. The other mistake is if you acquit a not innocent person, a guilty person, right, and you set them free. That's a type 2 error. Now, when you are asked to work on these problems, typically they're free response, or they could show up as multiple choice actually as well. But a lot of times they'll say like, which is worse for a particular party, like for the company or for the purchaser or for the, whomever. So it's not like both of these are mistakes, right? I'm not trying to say like which is worse, because they both have different, implications. Putting a innocent person in jail is bad, 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 bad. But setting a guilty person free is also bad, right? But they're bad in different ways. So when you're looking at it, sometimes they'll just say, what are the consequences of each, instead of like, which is worse and why. All right. So if we check out a different example, let's talk about this guy. Let's talk about jumping in a pool. All right. And if we're jumping in a pool, my null hypothesis, let's say you're blindfolded and you're going to take a leap of faith and jump in a pool. Well, if the pool is full or the pool is not full or empty, we have very different scenarios going on. Okay, so if you decide that the null hypothesis is true, that means that it's full. If you decide that the null hypothesis is false, that means that's out and this is in. That means it's not full. Okay, if you reject the null, that means you're going to say, nope, the pool is not full. I think it's not full, so I'm gonna not jump. But if I don't reject the null, that means I'm going to declare that the pool is full, which means I'm going to jump. So we have two correct decisions, right? If you don't jump and it wasn't full, then you did the right thing. Okay, if you jump in the pool and it's full of water, you did the right thing. Okay, if you don't jump and it was full, right, you reject your null and your null was true. That's a type 1 error. You missed out on a lovely day of swimming. Yes, that's a mistake. Okay, it's not a catastrophic mistake, but it's a mistake. You didn't jump and you missed out on some fun swimming. The other mistake in this case, if you don't reject the null, that means you're going to think that the pool is full and you're going to jump, but in truth the pool was not full and you're jumping in an empty pool, and now we have a catastrophe. Okay, and that would be your type 2 in this problem. So sometimes clearly there is a worse mistake, right? And sometimes, like back up here, they're both bad, right? And we're not going to get into an ethical debate about which is worse. That's a totally different course. But statistically speaking, right, with our alpha equals 0.05, that's the one that's typically accepted in the court of law. Faulty brakes, something goes wrong with the car and the car catches on fire, or something, a manufacturing piece is broken and it leads to something happening to a machine or, an item. There's all kinds of things like that. Hoverboards were catching on fire for a while. Oh my goodness, right? So like all that kind of stuff. Well, if you're going to have a class action lawsuit or a lawsuit against a company, there needs to be a threshold in which you can prove it guilty or not. And the typical, if you can prove it guilty at an alpha equals 0.05 or conclusive at alpha equals 0.05, that's typically accepted. Okay, alpha equals 0.01 is even better, but alpha equals 0.10, that means you have a 10% chance of making this type 1 error, and that's too high. All right, so what we're going to do is we're going to try some on your own with statistics. Okay, well, let's do one together with statistics. And what I want to show you as well, all right, is so for these next couple problems, we're going to write down our hypotheses. Like we talked about the other day, they're always going to pair together, right? Then you're going to state your type 1 and type 2 error, and you're going to describe the consequences of each. So what I want to show you, because I have found over the years that students can always write both of the mistakes down, but they sometimes have a hard time identifying which is the type 1 and which is the type 2. So a silly little trick to use is the type 2. Instead of do not reject the null hypothesis, you call it fail to reject the null hypothesis, right? Same as, so if it's type 2, it's fail to. Okay. I also find that as you guys get going and as you're starting to do this, it's really beneficial if you take the time to write it down, like what they are as a definition, and then underneath you put what they are in the context of the problem. These always must be in the context of the problem or they count for nothing. Okay, if it says like what's the type 1 error and you write reject the null when the null is true, you're going to get no points because it's not in the context of the problem. It doesn't actually answer a thing. All right. So if we have here, this is true. So 7 years ago, the national average for gas was $3.42 per gallon. All right. So if we take a sample of New Jersey gas prices, can we support the theory that we pay less for a gallon of gas? Now, we have more gas taxes than we did 7 years ago. You can ask your parents. But it used to be that, like, now we have like an extra 20 cents more gas tax than we used to. So think about it. This would be 20 cents higher if we have, or our gas prices would be 20 cents lower if you think about that. So gas is doing pretty okay right now. So null hypothesis is going to be the average is 3.419. And our alternate hypothesis is that we want to pay less. So we're going to have less than 3.419. All right. If we have a type 1 error, that means we're going to reject the null when the null is true, which means that we're saying we pay less than 3.419 for gas when we don't. All right. Back when I made this problem, gas prices were so high that there were people actually coming. We had such cheap gas compared to Pennsylvania and Delaware that people were driving over the bridge, waiting in these ridiculous lines at the gas stations right over the bridge by the river, and then paying the toll and going back and still saving money, like tons of money. So let's say that the conclusion was New Jersey pays less for gas. Well, if someone comes over the bridge thinking that they're going to pay less and they don't, that's a problem. Okay, that's a consequence. That's a big problem. The other one is going to be type 2, right? Saying we pay, fail to reject means we're going to go along with this. So saying we pay 3.419 for gas when what? The null hypothesis is false, which means we really pay less. Now for New Jersey, this is awesome, right? Like for residents, like we're going to get a better deal. We're going to pay less for gas. Great, right? Now for the business owners, that's bad because those businesses, if people would have come across the bridge to get gas from us and now they're not coming across the bridge, those business owners are going to be pretty upset that they missed the opportunity to have more customers, right? So there's always a couple lenses that you have to look at things from depending on who, is doing it. So what I want you guys to do is I want you to try this next one, number 8. Okay. A company claims to be able to increase a person's credit score by more than 40 points over the course of the year. So credit score, the higher your credit score, the better things are going, right? If you don't have a lot of debt and you pay your bills on time, you have a nice high credit score, which means it's easier for you to get loans and you get smaller interest rates when you get those loans. Okay. So pause, please pause, right? Be honest. Try this problem on your own. If you want, try it in pencil and then unpause. You should have your null hypothesis is mu equals 40. Your alternate is we want to increase it by more than 40. Okay. So your type 1 error would be saying that credit score increases by more than 40 points when it didn't. Okay, if you reject the null, that means you go along with this, but really this was true. So a consequence is that if a report finds that the company does a great job, people are all going to go to this company and then they're going to be mad that it didn't really come to fruition. Okay, and a type 2 is you fail to reject, which means you go along with this, but this was really true. So saying that credit score was 40 points when it was really more than 40. Okay, this is a problem for the company as well, because if research finds that the company isn't raising it by more than 40 points and they really are, they're going to miss out on customers because people aren't going to go to them because they don't think they're the best, when really they might be an amazing company. Okay, so that's also a mistake. All right. So this guy, right, the manager of a fast food restaurant, wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes to receive their food after their order is placed. Based on store records, the proportion of customers who had to wait longer than 2 minutes was P equals 0.63. To reduce this proportion, the manager assigns an additional employee to assist with drive-through orders. During the next month, the manager will collect a random sample of drive-through times and test the following hypotheses. So we're given our hypotheses, and where P is the true proportion of drive-through customers. So to write down your hypotheses, right, and go ahead, practice on your own. Try to figure out what they are, okay? A type 1 is going to be you reject the null when the null is true, which means the manager finds the proportion has been reduced when it really hasn't. The consequence, right, try to figure these out on your own, okay? What's a consequence of this? The consequence of this would be, well, if you think that a wait time has been reduced and it hasn't, your customers are still going to be annoyed. The boss thinks everything's fine and it's still not, and the customers are really going to be annoyed that they have to wait for their food. Okay. A type 2 error is when the manager finds the proportion has not been reduced and it actually has. And the reason why that's a mistake is that the manager might then think that his employees or her employees aren't doing the right thing, and they really are. They're doing a great job. They fixed the problem. So adding that extra employee to the drive-through orders that they did up here, okay, worked, and it was fine, and they fixed it, and then but the research says that they didn't fix it. So now the boss is going to go try something else when really that did the trick. Okay, so there are, your book does a lovely job explaining it. We will, of course, practice this, and I will talk to you soon.